Okay, if you don't know what two-factor authentication is, that's okay. By the end of this video, you'll know what it is, and you'll be able to know how to employ it to make your online life more secure. It's very simple conceptually. When you type in a password alone to access a website, you're using a single factor of authentication. Two-factor authentication adds a component to that you have possession of that is more secure than just your password alone. And when you use this second factor with your first factor, together it's called two-factor authentication. Okay, so first of all, let's talk about how people typically log into websites using only a password. That's the traditional way of logging into a system, where you go and specify a username and you type in a password, and you're granted access if the server recognizes your credentials. If you type in the wrong password or username, you will not be granted access. Now, password-only authentication has been with us for decades, and it really is something that's starting to be phased out because it's, relatively speaking, quite weak and quite insecure. Now, there are many reasons why it's weak and insecure, but just talking about the obvious things, first of all, a password is something you need to usually write down or store somewhere so you don't forget it. And when you write it down or store it somewhere, it leaves it open to somebody else finding it. Even worse, though, when you use a computer to type in your password, whether it's your home computer or a public computer, there could be malware installed or some other kind of software that's designed to capture the keystrokes that you type in. So a piece of software that's capturing keystrokes on a computer as you type them in is typically referred to, loosely speaking, as a keyboard logger. Now, keyboard loggers can come in a software format, but they can also come in a hardware format. And the more that technology advances, it's not impossible that there could be something very intricate put into a computer that could capture your passwords or other keystrokes as you're typing things in. In fact, this does exist today, but what I'm saying is, in non-obvious ways, that can happen to you. So let's talk about a couple of the main things that are really not great about a plain old password. One is it's a string of characters that you usually remember, or you write it down on a piece of paper, or you put it into a password manager. And that means you've got to store it somewhere. And if that is the way that you authenticate yourself to a computer system, what that means is that one password is the way that the computer system that you're communicating with validates that you are you. Now, the problem here with that is if the password is visible to others, or if somebody else can get the password, then that means somebody else can use the password, and the system that they use it with will think that it's you. In other words, a password is used to identify you as the person trying to access some server. But in reality, a password can be copied around. Somebody can get your password and use it, and there's nothing really physical about a password that is going to tie it to you and you alone. If somebody else gets your password, they can use it, and the system's not going to have any smarts to be able to know, oh, well, that is, that is Ashley, or that isn't Ashley. I wanted to give an analogy here that is going to help explain some things. Let's think for a second about the traditional way we handle answering the door at home. Let's say that there is a person named Sally who lives at home, and there's a person named Jane that comes to visit Sally. When Jane comes to the door, she rings the doorbell. Sally goes to the door and says, "Hello, who is it?" And Jane says, "It's me, Jane." Sally's brain recognizes Jane's voice and says, well, it sounds like Jane. Let me look out the peephole. So Sally looks out the peephole and sees that it's Jane, and Sally's brain says, oh, visually, it looks like Jane. So Sally, using the combination of Jane's voice and what it sounds like, as well as the visuals that Jane is actually present out there, has enough confidence that this is in fact Jane and can open the door and let Jane in and hi, how are you, and all that. What we just saw there is a form of authentication that took place using several different factors in a sense. One was the sound of Jane's voice. The other one was how Jane looks. And I think part of this actually too is the smarts of Sally. Sally has human brain capabilities and is able to ascertain the nature of the voice and the visuals of the person enough to see that it's valid and real, that it's not somebody outside holding up a photo of Jane, because that might look obviously fake, right? So it looks real enough, and there's enough sophistication there that that form of authentication kind of works there. Okay, so so that's the way human beings kind of interact. Let's kind of put this into a password oriented analogy. Let's say that Jane and Sally agree that when Jane comes to Sally's door, Jane is going to ring the doorbell 3 times. So when Sally hears the doorbell ring 3 times, she'll know it's Jane. Now, in this analogy, the number of times that the doorbell is going to be rung is actually a password. The password is that Jane will ring the doorbell 3 times. And when Jane rings the doorbell 3 times, Sally will know about it. But anybody can ring the doorbell 3 times, not only Jane. So as a factor of authentication, ringing the doorbell is a fairly weak factor if it doesn't accompany something else. So to show how weak this factor of authentication is, if Sally's at home and the doorbell rings 3 times and Sally goes to open the door blindly saying, well, it's got to be Jane because it rang 3 times, well, what's happening is Sally, if you look at her as in an analogy here, like she's a computer server, if she just opens the door based on a password that anybody could use, she doesn't really know if the person using it is actually the person who is associated with that password. And so that's the weakness of a password, is that anybody can possess it, not only the person who it belongs to. Now let's expand the analogy and add another factor. If Jane rings the doorbell 3 times and Sally goes downstairs, and instead of opening the door right away, let's say Sally asks for a second factor of authentication by saying, "Who is it?" Well, Jane will say, "It's me, Jane." And Sally will recognize, this is Jane's voice. I recognize it, and it was Jane's password. Now, it's probably okay for her to add a third factor in there by opening up the peek hole and seeing, oh yeah, visually that's Jane. But the analogy I'm trying to point out here is that by Jane adding additional factors, meaning methods of identifying who's there, it makes it more difficult for somebody to spoof or pretend that they're Jane. And that's the idea behind multiple factors of authentication. A password alone is very weak and can be forged by anybody who has the password. There's not much art in forging a password. If you've got the password, you can forge it. All you got to do is type it in on a keyboard. That's fairly weak. So if you add another factor of authentication where you're going to log into a system not only with a password, but the system is going to require you to insert a physical second factor of authentication, well, what's going to happen is the system is going to make sure that you're inserting the little device that only you should have. And these little devices are very difficult, theoretically considered sort of impossible for the average user or even average hacker to crack into, because the secrets that are kept on this are kept in a very secure way and physically with the individual who owns the key. So if I go and associate this with my Gmail account, I can insert this, type in my password, and Google will validate that I've inserted the key that only I have, which I have paired with Google at some point when I set this up, and we're going to go into that in a second. And once I do all that, when I sign in to Google, I'll use my password. Google will prompt me for this little second factor, and I insert this, and Google will verify that I'm inserting the one that only I should have in my possession. So if a hacker gets my password but doesn't have my physical key, the password's useless really without the physical key. So in short, from a high level, two-factor authentication means you're using 2 separate ways to identify who you are to a website or some sort of computer system or some sort of system that you want to access. And very often the 2 factors are your password and some physical device, like this YubiKey. Now, there's a lot of people out there that use SMS messages on a cell phone as a second factor of authentication. So the way SMS messages are used as a second factor is you'll log into, let's say, your Google account or something else, and what will happen is you'll get a code sent to your phone via SMS, which you can then type in as you're logging in. Now, that's all wonderful, but it's been determined that SMS is not really reaching the bar of security that's required to be considered a very rock-solid authenticator. Now, using SMS as a second factor of authentication is not horrible, but it's not the best second factor you can use, and it's actually been somewhat deprecated in recent years by being placed on what is known as the restricted authenticator list. Now, the organization that did this was NIST, which is the National Institute of Standards and Technology, and they actually do a lot of assessments of encryption standards and adoption of standards for government security, and a lot of organizations and companies might follow what NIST recommends, and NIST has put certain authenticators, and an authenticator is something like your password or using SMS. It's a set of technologies that's used to help perform authentication. To get the specific definitions of all this, you can look at the links below to some of the NIST documents if you're really into that. If you want to also find some high levels, you can do a web search for NIST SMS second factor of authentication, and you'll find plenty of news articles that talk about SMS and the weaknesses relating to it. But the bottom line is, using your cell phone with SMS as a second factor of authentication is not horrible, and it's certainly better than just using a password alone. But there's enough information out there that is hinting that SMS has enough weaknesses to it that it can be hacked, and that it's not going to be as secure as a real separate physical second factor of authentication. When you use SMS messages, your cell phone could get hijacked any number of different ways. In fact, there was one case where somebody's phone did get hijacked, meaning they actually reassigned the phone number to a device that was in the realm of the hackers, and then the hackers went and reset somebody's password to gain access to all their accounts, and they could reset those passwords using the phone because they were receiving all the SMS text messages. But that's just one way. I mean, SMS is not exactly the most secure thing. Everything you get comes in clear text and visible. So there's a lot of different ways that could be hacked. This YubiKey is a universal second factor device, meaning it's following the universal second factor standards, the set of standards associated with the universal second factor, and it means you can actually insert this thing into a standard old PC USB port, and software on the PC can interact with this to help achieve more robust authentication via using this as a second factor. When you use a device like this universal second factor device, this device has a secret on it which is unique to this device. And that is sort of the basis for what makes this device so good, because that secret, which is like think of it as a really long, unique number, unique to this device. So using that secret, this device can do some things that only this device can do. This device not only has that secret, but it's also a miniature computer, and it can use that secret to encrypt things in a way that only it knows how to encrypt. And that's the basis for how this device works in the case of authenticating to Google, for example, or other universal second factor websites. The way you will present this secret is you will insert this key at the time you authenticate. So what you will do is you will sign in with your password. Google will prompt you to insert this physical device that only you have. You'll insert this on your computer. Google will then send some information down to this key that this key will process with its unique secret, which is on this key, and it will send it back to the Google server. And after the data gets sent back from this key through the computer, through Chrome, to the Google servers, the Google servers will then be able to identify that it was the unique key that you physically have that was able to crunch data and send back a very unique code that you couldn't have done if you didn't have this device with the unique secret that is on this device. So in a sense, when you're using a second factor of authentication, you're using an additional password. But the password is not one that you type in or talk about out loud. It's one that you use by inserting this little key into your computer, and Google will send down some information to this key, and this key will do some things that only it can do because of the secret which is on this key, and it will send that back. So when Google gets the data, it will verify that it was communicating with the key that shares the secret with it. So I'm going to go through an example of how to register this device with Google, as well as how to authenticate with it, so you can see that. But before I do that, let me explain from a high level what happens. And this is a very high level. It's missing a lot of detail, which perhaps I could make another video about, but it's really the kind of stuff that most end users are not going to really want to get into. So what happens when you want to use this device with, let's say, your Google account? You'll go to the Google security settings and you'll choose the option to add a key, and this is a key. So you'll go to add a security key and you'll follow the steps. It's very simple. We're going to go through that in a second, and you'll insert this key in your laptop in the USB drive. When Google prompts you, you'll touch this little capacitive touch area here, and that lets this device communicate with the laptop temporarily to do some work to establish its relationship with the Google service. At that time, Google will send down a special piece of information that this device, using its secret that it knows about, it will take its secret and use the information that Google sends down, and it will create a new secret. And that secret or private key will also be used to create a public key, and that public key will go back to Google as part of the response when you're setting up the key. Now, if you don't know about public key cryptography, this is just the real high level. The user who has the private key can do something with a piece of data and send it to somebody with the public key, and that person with the public key can verify that it in fact was the person with the private key who did that thing with the data. And that's how two sides of a conversation can identify one another using public key cryptography. It can become a complex subject, but I really do believe for end users who are not savvy about cryptography, the basic concepts of public key cryptography are not highly complex to understand. It's just when you get into the mathematics of it and the algorithms involved, there's a lot of subtleties and things that when you're implementing systems, you've got to be very careful of, and it's very difficult to implement good systems, and that's a whole different subject. But the gist is there's a lot more to this, of course, for the people who create these technologies. But from a high level, you as a user just need to be concerned about secrets and public keys and where they may be stored, and you really don't even have to think about all that. I'm just explaining it because it might be a little fun for you to have some basic understanding of what's going on. So what this means is when Google uses this to authenticate you, it's pretty much going to require you to be the person that has this, or somebody's going to have this with your password. And as long as you don't lose this along with your password, you'll be safe. So like if you just keep this somewhere safe, you'll be able to use it to actually log into Google, and to do so in a way that requires you to have this. So even if a hacker gets your password, they can't use your password alone to log in. They need this key with its secret. And if you compare that with to the SMS scenario, we already know that you can hijack a phone number, right? That can be done. That has been done, and it caused somebody to get hacked. Once the phone number was hijacked, the hackers were able to actually change somebody's account passwords using the hijacked phone. But that's not the only way that I can think of that you can actually hack SMS messages in that whole paradigm. So when you have this unique key, nobody's going to hijack this key. This key is just your key. It's with you, and it requires this key to be present. So if you go to a Chrome browser and you log into your Google account with a password and it asks you to insert this, chances are it's you that's logging in and not somebody else. I mean, it can't be somebody else unless they've stolen your key. And if they've stolen your key, well, then they've stolen your key. Hopefully they don't, you don't write your password on the back of the key, because then somebody could steal your key and have your password, and you don't want somebody to do that. Now you can use YubiKey to actually authenticate with universal second factor compliant sites, but you can also use this key to actually authenticate with a password manager on your local computer or your smartphone. So what you can do is you can use this key to protect your password manager, and the way you do that is very similar to the way you might register with the Google service, except you're going to register your password manager or its file that it stores your passwords in with this device. Now, it's done slightly different with different password managers, but the concepts are kind of the same. If you have a password manager and you're protecting it with just a password alone, that means if a hacker hacks into your computer and steals your password manager database file, and if they have a keyboard logger on your computer, they're going to maybe be able to get your password as well as your password manager file, and with that they can open up the whole thing and gain access to all your other passwords. When you use something like a YubiKey to help lock your password database, it requires you to enter your password for your password database along with inserting this. If you don't have this, you can't access the password database, even if you have the password, the typed password. So that means if a hacker steals your password database file, and let's say they know your password from a keyboard logger, but they don't have this physical device, they're not going to have the cryptographic information necessary to crack open your password database. This assumes, of course, that the architecture and design of your password database system and file and all that is in good form, and hopefully the password manager folks are doing that correctly with their respective products. The strength of any cryptographic system is really the weakest link in the entire system. So whatever the weakest link is, that's pretty much the strength of the entire system. For example, you can have a $1,000 lock on your front door of your home, but if you have a flimsy glass window right next to the door, it's not really going to stop somebody from breaking that glass and opening the door. It's not that the $1,000 lock is bad, but the $1,000 lock is only going to be as good as it will stop somebody who is not willing to break the glass, is one way to look at it. Okay, so with all the verbiage out of the way, let's get into actually going through the steps here of actually registering the key and actually using it to authenticate. Okay, what I want to do is associate my YubiKey with a Gmail account. So the first thing I'm going to do is log into the Gmail account. After logging in, I'm going to go to the account settings. Then I'll click on signing into Google. And then you'll notice that two-step verification is off. So I will click on that, and it takes me to protect your account with two-step verification. Let's click Get Started. Enter our password. I'll click Choose Another Option. Then I'll choose Security Key. Now it's asking if I have my security key and that it's not connected, and I do have it. It's not plugged in. I'll click Next. It now wants me to insert the security key, so I will insert it. I'll now press the button on the security key. I'll click Allow to allow the browser to talk with the security key. I'm now going to name this security key. I'll call it My Demo Security Key. I'll click Done. And you'll see it shows me that I've now added a security key. I can add other security keys if I want to have a duplicate, and I would always recommend having at least 2 or more security keys. So if I buy a security key, I'll actually buy 2, and I'll associate both with the account. Now let's try out the security key to see if it works. So I will now sign out. I'll now log into the account. It's asking for the password. And now the password, as you notice, was not enough to log in. It's now asking me for the security key. I'll insert the security key and press the button on it. Google will verify that the security key is valid, and it will let me log in. I'm now logged in. If I didn't have the security key, it wouldn't let me log in. Okay, so we've paired this YubiKey with a Google account. Now let's take this and install a password manager and pair this with a password manager so that we can only access the password manager if we have this YubiKey. So for this demonstration, I'm going to use Password Safe with YubiKey because it's freely available for download. It's open source. It's been around for a while. The source code is available because it's open source. And it does work with YubiKey. There are some other password managers that work with YubiKey, so you're welcome to go to the YubiCo website to actually look at some of the other products that work with YubiKey. So let's get started with Password Safe. If I want to download Password Safe, I'll go to a search engine and I'll type in Password Safe. What we're looking for is pwsafe.org. Sometimes it's the first result. Otherwise, it's usually one of the top results. So I'm going to click on this one. This is pwsafe.org. And it takes us here, and there's a download link right here. And then one thing to be aware of here on this mirror site is there are some ads that are hosted in little banners, and sometimes they have buttons. This one actually doesn't have one of those buttons, but sometimes it has a button that looks like a download button. Don't confuse that with the download links, which are shown right here. So the first one is a 32-bit installer. That's the one we're going to use today. There's a 64-bit installer. You don't really need the 64-bit version, though, because the 32-bit version will work on 32-bit Windows as well as 64-bit Windows. And this last one you can probably ignore because it's for Windows XP, but if you still use Windows XP, they do actually have a download for this. So I'm going to click this first link here, and it's going to download Password Safe. That's one way to download Password Safe. I'm going to go back here to the main page, and I just wanted to show you quickly what I normally do to download Password Safe. What I do is I go here to the SourceForge website, and this is the main Password Safe SourceForge page. I am familiar with SourceForge as a website to download open source programs from, and so therefore I'm a little bit more comfortable with it. And you'll see there's a download button here. This will download the 32-bit version from SourceForge, and I usually feel better using this download. And then SourceForge, after you click on that, will begin the download after a few seconds, and there's the download. And that's the same download as was on the mirror site on that first link that I just showed you. Now, there are various ways in which you can validate and double check that your download is good when you download open source. That is not the subject of this video, so I'm not going to cover any of that. I'm basically going to install the password manager so I can actually show it working with the second factor of authentication. And after the download's complete, I'll open the downloads folder and copy the installer to the desktop so that we can use it from here. So we're going to launch the installer and just choose all the defaults here and install it to the default location. So then we start up Password Safe. So the first time we start it up, we're going to create our safe by clicking on New. So I'm going to create this off the root in a folder called My Safe. You can put it in the default location or choose your own location. And I'll just call this My Password Safe. And then we have to choose a password. I'm just going to choose a quickie password right now. And the password safe is created. Now if I were to close the password safe, and then go to reopen the password safe. And now it wants the password. Okay, so we have a new password safe created, and we can open it with just a plain old password. So I've exited Password Safe here, and if we start it up, you'll notice that the default safe is the one that we just created, and then we can enter in our password. It opens it up. Okay, so now we have a regular old Password Safe file, and we can actually, create a new password. Like I can say, my password, and the username might be user123, and then you can have this thing generate a password. And there's a whole bunch of features up here that I'm not going to go into right now as I talk about this, because this is not really a video about this password manager. I'm just showing that you can actually create an entry in the password safe, and it's asking if I want to use that as my default username, and I'll just say no. And so now we have a password entry, and we can create a number of those we want to. But what we want to do is we want to actually protect this with a YubiKey. If I go and open this, I can just open this with the regular old password I just created. I don't need to insert the YubiKey. So in order to pair this password safe with the YubiKey, we basically insert the YubiKey, And then we go here and we choose YubiKey. And when we choose YubiKey, we click Generate, and then we click Set YubiKey, and then we click Close. And after we do that, we now need to change the password safe combination. The old safe password is the one that I've been entering, and we don't need to click this YubiKey button here. I'll explain that in a second. But what we're going to do is change the password to the same password. Okay, so there's going to be no change in this text that we have to enter. But what I'm going to do is I'm going to click the YubiKey button, and then I'm going to press the little button on the YubiKey, the little sensor, so that it will change the password to a password that requires not only the text that I entered, but also it will require the physical YubiKey to be inserted. And the way that happens is basically the YubiKey has that little secret that we generated and put on the key. And when we type in the text for our password and we click on that YubiKey button and we press the sensor, basically the YubiKey takes our password text, it actually gets sent to the YubiKey, and when the YubiKey receives your password that you entered, it does some special number crunching, cryptographic operations that it performs using the secret that we set it with earlier as part of the initial setup of the YubiKey for the password manager. The YubiKey will then take the result of that and send it back to the password manager. That result is the final password. In a sense, you can think of it like this. Your actual password is not only something you know, that text you enter, but the result of those cryptographic operations that only the YubiKey can perform. This means that if somebody steals just your password database file, but they don't have your physical YubiKey, they can't open your password manager file because they don't have the cryptographic secret on that YubiKey. So basically now the password file is associated with the YubiKey. So if I go here and close this, and then I go here and I open this, and if I remove the YubiKey and just type in our old password, it will not let me open the safe with the old password. I mean, it's physically impossible for this thing to do it because it doesn't have the YubiKey. The YubiKey has a secret. That's that thing we generated and set on the key. And without that secret being present, our password alone is not enough. So if I go and insert the YubiKey, and we don't really have to type anything because what I typed is already there, but I'm going to just type in again the password so you can see I typed in text, which I know. That's in my brain and I know that. But now I'm going to click the YubiKey button and I'm going to press the sensor on the YubiKey, and the YubiKey will use the secret that it knows. I don't really remember that or know that. The YubiKey has that inside of its memory, and it's actually going to use that secret along with a challenge that is sent from the password database here. When I press the sensor, it's going to process that and respond back. And when it responds back, it gives this password database the information it needs to decrypt the database. So basically what we can do is access this safe only when we have the YubiKey inserted. The YubiKey contains a secret, and the other half of the secret is the password that we type in. And we can actually change these things. If I go here and I want to change my safe, I can actually type in the old password right here. And what I have to do is, since my safe is currently associated with the YubiKey, I can only change it by including the YubiKey as the original old password because it is part of the old password. So if I click on YubiKey and now I touch the sensor on the YubiKey, that password has now been verified. Now I can type in a new password, and I'll just call this like new password 123, new password 123. And now I'm not going to press the second YubiKey button, and I'm just going to press OK, and this will remove the YubiKey from the password. So I'll click OK. Now I'll click Close. Now I'm going to click to open this, and I'm going to remove the YubiKey. And now I'm going to type in new password $123 and just OK, and it will open with just the text password because we didn't click the YubiKey button, so the new password was no longer associated with the YubiKey. We disconnected it. So now we're back to sort of an old school password setup. So now if I want to go and associate the YubiKey with that new password, I can go here and I will insert the YubiKey. I'll type in that new password. That is the old password, is new password, meaning it's the current one, and we want to change it. Now that current password is not associated with the YubiKey, so we don't need to click this when changing from this old password because it's not associated with the YubiKey. But we want the new password to be associated with the YubiKey, and the new password is actually going to be the same password, which is new password $123. Whoops, I must have done something wrong there. New password $123, new password $123. And because we want this new password, which is actually the same text as the old password, but we're going to add something new here, which is the YubiKey. And in this case, we do press the YubiKey here, and then we touch the sensor. And when it comes back, it closes this because we've now changed the password to be not only that text, new password $123, but the password also technically is the YubiKey as well. In other words, your password is the YubiKey plus the part that you know. And if you don't have both of those together, the password safe can't be opened. Okay, so let's close this. So I'm going to go test the new change. So we type in our new password, which is new password $123, and we press the YubiKey button, and then we will press on the sensor on the YubiKey, and boom, it opens up our password. Now if I close this, and I remove the YubiKey, and then I go to try to, whoops, we don't want that, sorry. We go to open the password safe. Now I'm just going to type in new password $123. And we can't even press on this because I've removed the key. But if I click on this, it won't work because technically the way you need to look at this is you've typed in the text part of the password that you know, but the YubiKey isn't inserted. And unless you insert the YubiKey and press on the sensor, you technically haven't entered, quote unquote, the whole password, because entry of the password is no longer just typing on the keyboard alone. It's actually typing on the keyboard and inserting a physical device that only you have, and you insert it and you have to press the sensor on the YubiKey because the sensor prevents the YubiKey from being used by malware that might infect your system without you knowing, because the key requires you to physically press that sensor, and without that, the secret on this key can't be accessed to process password data, so a malware program can't go and try to do a brute force attack using your inserted YubiKey. So if we insert the YubiKey, and we just click on the YubiKey button here on the UI, and then we click on the sensor on the YubiKey, it opens up the file. Keep in mind that the concepts I'm talking about here will be applicable to other password managers, although there may be some differences depending on how those other password managers use the YubiKey. Now that we're done pairing that password safe database with this YubiKey, we can actually take that password database file and copy it to Android as an example, and download the password safe program for Android, and we can use an NFC-capable YubiKey that we pair with the database to actually access the database in the same way that we can do so from the laptop. Not all YubiKeys support NFC, only some of them do. Specifically, the YubiKey NEO supports NFC and USB and can work for both. But the regular YubiKey actually does not have NFC. So just keep that in mind if you shop for a YubiKey or some other security key. If you want to use it with your smartphone, and your smartphone has NFC and you're planning to use NFC, make sure it supports NFC. Well, that's it for this little demonstration here. This is not a deep dive into password managers or Google security or anything like that. It's really just an introduction to two-factor authentication using YubiKey. This is a product I really like. It's not too expensive, and it offers a little bit of assurance beyond just plain old passwords. I hope you really enjoyed the demonstrations and the overview in this video. If you like this video, I hope you'll click like below, and if you want to subscribe to this channel, there's a little subscribe button down below, and I hope you'll click on subscribe. All right, that's it. Thank you very much, everybody. Have a great one, and until the next video, be well.